Hi guys, and welcome to your first lesson on your medical math class, your online class. We're looking at whole numbers today. That's the first thing we want to take a look at. You're going to see actually two lectures today. We're going to first look at whole numbers, and then I'm going to introduce really a lot of the same things we do in this chapter. We're going to take a look at our decimals and do the same things. So first, talking about whole numbers. What I mean by whole numbers when I say whole numbers itself, I want you guys to think about a number line. You guys may have seen a number line before. That's a horribly drawn line, and I apologize for that. But when we think about where numbers fall in counting order, so here's 0 on the number line, and when I start moving to the right here, we count 1, 2, 3, 4, 5, and so on and so forth. I could obviously keep going on and on and on. When I go to the left of 0, that's where we're going to see -1, -2, -3, -4, and just like we did on the right, I could go on and on and on forever, but I'm going to stop here. Whole numbers include these numbers, where we're not seeing decimals, we're not seeing fractions. When we get into our decimals chapter, we'll be able to see that, halfway between 2 and 3, for instance, that's 2.5. That's the halfway point between 2 and 3. 2.5 is actually the same thing as the fraction 2.5, and we'll see that in next week's lecture when we deal with fractions. So whole numbers do not include these types of numbers. Whole numbers are just these. What we're seeing is we're counting our numbers here. So that's what we want to take a look at. First, before we start getting into different operations with whole numbers, I want to show you guys just to understand a relationship between our whole numbers. What we're going to first take a look at is how we compare these numbers. Excuse me. Obviously, when we're going to the right on the number line, you guys can see on the screen there our numbers are getting larger. When we count 1, 2, 3, 4, 5, and then I could keep going all the way to, 6,432, and obviously that's a very big number. But those are, getting larger. As I go left on the number line, our numbers are getting smaller. So, 1 right here is a very small number. So, how we can compare our whole numbers would be, for instance, if I had the number 8 and I wanted to know what that was compared to the number 657, something like that. Obviously, 8 is smaller than 657. So the first part of this chapter, we're looking at how we compare these numbers using these following symbols. If I saw this one, that means greater than. This symbol means less than. This symbol we know means equal to. And then we see two other symbols, greater than, and then there's a line underneath it, and that shows that it's greater than and equal to, and we'll get to that. And then this is less than and equal to, so very similar. So using one of these symbols over here, again, since 8 is smaller than 657, we're going to use the symbol less than, and then that completes this number statement, and it says 8 is less than 657 now. Whereas if this was reversed and it was 657 compared to 8, then I would use the symbol greater than to show that 657 is greater than 8. We just read that in order there. That's that the completion of that number statement. And as silly as it sounds, the way that I've always remembered these symbols, always remember that the alligator eats the bigger number. So in both cases, you guys can see the alligator is eating the 657, so it's eating the larger number. So if that helps, again, I know that's kind of a silly way of thinking about that, but it's always helped me, and it still does to this day. So in looking at other places where we would see how we can compare that, sometimes you might see more than just that. You might see how about if I asked you guys to compare 4 plus 6, and I want to know what that is compared to, say, 22. Well, again, in the addition problem over here, obviously 4 plus 6 is 10, and then this is just 22. So I'm looking at the number statement completion for what is 10 compared to 22, and that is less than 22. So you may see problems like that where you have to actually perform the calculation. We again can see equal to, if I asked you guys what is let's say 2 nickels compared to, let's say, 10 cents. Well, 2 nickels, we know 2 nickels, a nickel is 5 cents, so 2 of those would be 10 cents. So 10 cents compared to 10 cents, we would use a symbol equal to. They're the same on either side, even though they don't look the same, but again, they still add up to the same amount of money. So that's another way we might compare these whole numbers here. Another way that you might see a comparison, I want to show you guys where we see those symbols less than and equal to, and greater than and equal to. In situations where maybe it says, let's say, how you guys would see this, if I said the numbers 7, 8, and 9, so these 3 numbers here are what compared to the number 9? Well, in this particular case, the numbers 7 and 8 I know are less than this number 9 over here. So I'm going to use that symbol less than. But because 9 is here and here, that means that the numbers over here on the left, so over here on this side, are either less than and equal to the numbers over here on the right. So, and just circling that, the number over here on the right, that the numbers over here are either, again, because 7 and 8 are less than, and the number 9 is equal to the number on the right, we would use the symbol that says both, that it's less than and equal to. So that completed number statement says the numbers 7, 8, and 9 are both less than and equal to the number 9. So that's another place where you might see that relationship. There's an example that's mentioned in the book that says if I said that age is less than and equal to 5, say for instance, there's a pediatric medication that is for children 5 and under. That means that the age can include children that are 5 years old. If that little line, if that wasn't there, if that statement just said age less than 5, then that means 5-year-olds are not included. That means only children that are 4, 3, 2, 1, those are the only ones that can take this medicine. 5-year-olds need something more. But because that little line is there, that just simply means that that age is going to include those that are 5 years old as well. So that's what that means. When we see those statements, those particular lines, you guys will see that that means both. So that's how the way we can compare whole numbers, and so you guys will see that on your all's first assignment. So the comparison, remember those symbols, and that again just shows the relationship between those. Okay, so now we'll go ahead and jump into our addition of whole numbers. So addition of whole numbers, when we're adding, anytime you're adding 2 numbers, we want to make sure we line up our numbers. So let's say 247, and I'm adding 13, so that's kind of an easier one. Actually, let's say 93, so I can show you what happens here. We line everything up according to the very right digit, which is going to be called the ones place. When we get into rounding a little bit later, I'm going to better explain the place values. But our ones place is the very far right digit, so we want to make sure it's lined up by that. So even though the top number has 3 numbers in it and the bottom number has 2 numbers in it, as long as we're lined up according to this place value, the ones place, then our tens place will be lined up, and our hundreds place here will be lined up. There just doesn't happen to be a hundreds place there, so we can look at that as 0. So as we add numbers together, and so I'll go through this fairly quickly because most people have a pretty okay time with adding. What we're going to do is start on the very far right side, so adding 7 plus 3 first. We know 7 plus 3 is 10. So again, I put my 0 down and carry my 1, and that 1 will now get added to our tens place column here. So I'm going to add 1 plus 4 plus 9, which is 14. So I'm going to put my 4 down and carry my 1, and then 1 plus 2 is 3. So since there's no more numbers to add, that is our completed answer. So I always go through that pretty quickly. If you guys have any issues with addition, please let me know. But we'll see that again in the next chapter when we get into our decimals chapter as well. So that's how adding takes place. We just always want to make sure we're carrying our values, and don't forget to add those in when those need to be. Subtraction, we actually treat the exact same way. With subtraction, we're going to go ahead and line those up again. So 247, and I'm going to subtract 93. In this case, the difference is I'm just subtracting the bottom number away from the top number, and we want to make sure we're borrowing when we need to. Like here when I'm subtracting 7 minus 3, that's easily done. 7 take away 3 we know is 4. But in the next column here, what I meant by borrowing is you notice that in the next column it says 4 minus 9. I can't take 9 away from 4 because 9 is bigger than 4. So what I'm going to have to do here in this situation, I'm going to have to borrow. What I do when I borrow is I go to the next column over and I borrow from that 2. We always just take away 1. So I'm going to take away 1 and make that 1 less. So 1 less than 2 would be 1. So that's what I mean by that. And then in order for us, why we were doing that is because what that does is allows me to add a 1 in front of that 4 now. It's kind of like we're borrowing, when you borrow from the place value in front, it's almost like you're borrowing 10. So 10 plus 4 is 14. So that's where that's going to come in. So what that does is that makes that, larger now to where I can subtract. And now I have 14 minus 9. And 14 minus 9 is 5. So I'm going to go ahead and write that down there. Let me change my marker color here. There we go. And 14 minus 9, there we get 5. And in the next column I have 1, but again this empty space here can be just treated as a 0. So 1 minus 0 I know is 1. So my answer here is 154. So I hope that helps with subtraction. Again, we're going to see some subtraction in our decimals chapter, so if you want to see some more exposure to that subtraction, we'll see that there. I am going to spend a little bit more time, let me get that whole numbers statement out of the way there. I'm going to spend a little bit more time on the multiplication and division of our whole numbers. We will see that again in our decimals chapter, but because multiplication and division involves a few more steps, there's a little bit more time spent on that. So with multiplication, in multiplication of whole numbers, we still line those up according to the ones place. So I'm going to actually work with some bigger numbers here. Well, let's start small and then I'll get into some bigger ones. So if I have, let's do the same, oh, whoops, I didn't want to do that. Let me switch my, let me get that out of the way here. Get rid of that. Okay. So I'm going to actually work with the same two numbers again. Let's say we have 247, and let's once again multiply by 93. So again, you're seeing the same lineup. That again, they're lined up according to the 7 and the 3, the very far right-hand digit there. And again, I'm going to work, the same way we were. I'm going to work from left to right, so the same way we did in the addition and subtraction. However, we're going to start with just the bottom number. So starting on the left of the bottom number, what's going to happen is I'm going to work left to right by multiplying that 3 by each digit in the top number. So I'm going to start with 3 times 7, and then I'm going to write my answer down here on this line underneath. Then I'm going to work with 3 times 4, then 3 times 2. So just working one at a time, just going to each individual number. Then what's going to happen is I'll do the same thing with the 9 and write the answer underneath that. So let's walk through this one together here. So with 247 times 93, again I start with the 3. So I'm going to take 3 times 7 first. 3 times 7 is 21. So I put my 1 down, carry my 2. What happens with that 2 is in the next multiplication problem, so let me actually get this out of the way. The next multiplication problem is going to be 3 times 4 now. So when I multiply those two, I'm going to add the 2. So 3 times 4 is 12, but plus 2 gives me 14. So I put my 4 down and carry my 1, and the same situation happens in the next problem. When now I multiply, the next step is going to be 3 times 2, that 1 will be added. So 3 times 2 is 6, plus 1 gives me 7. So I write that answer down. So there's my multiplication of the 3. Since I don't have any more numbers to multiply, I'm finished with that. I'm going to go ahead and erase these carried values and move on now to the next number. For you guys doing it on paper, you can always just cross out those carried values, and that should help. So let's move on to the 9. But what happens, and you guys may remember this when you were first taught multiplication, but when we move on to a new place value, before I write my answer down, I'm going to write the answer down on the next line underneath where it says 741. But before I do that, I have to add a 0 down here. Anytime you move on to a new place value, a new 0 gets added. And I'll show you an example here in a second where I use bigger numbers and where more will have to be added. So I add a 0 first, and now I'm going to move on to that 7. So when I multiply now that 9, oh, sorry, not multiply the 7. I multiply the 9, so 9 times 7 is what's going to take place first. So just like we did in that first, with the multiplication of the 3, I'm going to start with 9 times 7, and then I'm going to take 9 times 4, and then 9 times 2. So let's work through that one at a time. So starting with 9 times 7, 9 times 7 is 63. So again, we put the 3 down and I carry the 6. What's going to happen with that 6 is it's going to get added in the next multiplication step. So now 9 times 4 is 36, but then plus 6 is going to be 42. So let me put my 2 down and carry the 4. So now the next step is 9 times 2. 9 times 2 is 18, but plus 4 is 22. Okay, so now I don't have any more numbers to multiply. There's nothing left over, after we've multiplied the 9 out, there's nothing over here, so I'm finished. What happens now is I'm going to add all my numbers, these two answers together, because again, this was the answer for multiplying that 3 out. This was the answer for multiplying the 9. If there were more, there would be more answer lines here. But since that's all I had in that bottom number, these are the only two answers we have. What we do is we simply just add those two together now. So starting again on the far left, on the far right, and working my way right to left. So I'm going to start 1 plus 0 is 1. 4 plus 3 is 7. 7 plus 2 is 9. And now again, the 2 doesn't have anything, those 2's don't have anything to be added to, so we treat that as 0, 0 plus 2, and then 0 plus 2. So we get 22,971. And because there's more steps involved in multiplication, I always suggest that you use your calculator, just double check. If you put 247 times 93 in your calculator, it will give you 22,971, which means that we did all the steps right. It's really easy to sometimes forget to add one of your carried values up here, or incorrectly multiply something. Say I accidentally said 62 instead of 63 in that first, 9 times 7. Easily done. It's also easy to forget to add a 0. So there's just so many steps that sometimes are easily forgotten. So being able to double check that on your calculator makes that a lot simpler to, to make sure that you're doing that correctly. Just to make sure you didn't leave out any steps, So let's actually try a different one. Let me get this out of your way and let me show you a different example. Okay, so let's say let's work with a bigger number now. Let's say 2,453, and let's multiply by 162, let's say. Okay, so again, I'm multiplying these two numbers, so they're lined up according to the very far right-hand number there, so the 3 and the 2, so there's our ones place. And we're going to work again from right to left. As I've mentioned before, that we always work from right to left, but it's starting with the right number on the bottom, the very far right digit on the bottom number, and we're going to work right to left with the top number in each one. So it's going to be 2 times 3, then 2 times 5, then 2 times 4, then 2 times 2, and then we'll move on to the 6. So just like we did in the last example. So let's go ahead and do that. So starting with that 2, we know that 2 times 3, so starting right there at the beginning, is 6. Nothing to carry, so nothing gets carried to the next line there. But 2 times 5 is my next multiplication problem. So 2 times 5 is 10, and I will have something to carry now, so that 1 gets carried to the next number that I'm going to multiply, and that's going to get added again. So 2 times 4 now, so this is, again, just to follow along, this is 2 times 4 now. 2 times 4 is 8, but plus 1 is 9. So I'm going to erase that right there. So there's nothing to carry in that case, so I go ahead and multiply the next number. The last one over here, 2 times 2, gives me 4. Okay, so we're finished multiplying that 2 out. So again, I'm going to erase that carried value before I move on to the next place value. So now I'm going to move on to the 6. So that was me multiplying that 2. Now I'm going to move on to the 6 and multiply by each place value, or each place value of the top number. So again, working our way from right to left. But again, before we start with that 6, I need to add a 0 to my next answer line, and then I can start multiplying. So 6 times 3 is 18. I carry my 1. Now my next step is 6 times 5, which is 30. but plus 1 is 31, so I carry my 3. Next step is 6 times 4, which is 24, but plus 3 is 27, I carry my 2. Then I take 6 times 2, which is 12, but plus 2 is 14. So there's my answer for my 6 there. So now I'm going to go ahead and erase those carried values, and I'll move on to the 1. So now before I move on to the 1, because I'm moving on to the third place value over here now, I now add 2 zeros. With each movement, each number that you move on to, more zeros are going to be added. If there was another number in front of that 1, so say it was like something 1,162 instead, then my next answer line would have 3 zeros on it. So we would keep going, continually adding zeros with each number that we move on to. So now I'll go ahead and multiply that 1 out. 1s are easy. 1 times 3, 1 times 5, 1 times 4, 1 times 2. So we get the same thing, same numbers there. And once again, just like on the last one, I don't have any more numbers to multiply out here, so I'm going to go ahead and just add these values together. So let's add these down here at the bottom, starting at the right and moving left. 6 plus 0 plus 0 down here is 6. 0 plus 8 plus 0 is 8. 4 plus 1 plus 9 plus 1 plus 3 is 13. I carry my 1. 1 plus 4 plus 7 plus 5 is 17. Carry my 1. 1 plus 4 plus 4 is 9. And then over on the next column there, 1 plus 2 is 3. So our answer here is 397,386. But let me go ahead and double check that in my calculator. As I mentioned, let's do that. Check the original one, 2,453 times 162. It does give us 397,386. So that means we did all the steps correctly and we got the right answer. So it's a great way to just double check that. So I hope that helps with that multiplication. Again, we're going to see the multiplication in the decimals chapter, so hopefully that gets you on the right path with that, and we'll see kind of a very similar process in our decimals chapter. Okay, so let's get this out of the way and let's move on to division now. So division, you may actually see it written a number of different ways. You may see division, and let me just give an example. Let's say we have, 645 divided by 4. If we have something like that, you might see it written that way. Division can sometimes be written as a fraction. You may even see it this way. But the best way to write division, to actually do this by hand, is to write it in this bracket form, 645 divided by 4, where the number that you're dividing by goes on the outside and the number that you're dividing up goes on the inside. So what I mean by that, in this particular example, let's say we have 645 Skittles, and we want to distribute that evenly to 4 people. We want to make sure everybody gets the same amount of Skittles, so we divide that to see how many Skittles each person should get. So the total amount of Skittles we have goes on the inside of the bracket, and the number that we're dividing it by, so how many people we have, goes on the outside. So 645 Skittles divided by 4 people, and that's how that would look. So let me rewrite this up here at the top so we can see this. So 645 Skittles divided by 4 people. Let's see how many Skittles everybody gets. So what happens with this when we're dividing this out, and I'll walk you guys through this as we do it, we're going to take this one step at a time. We're going to look at the 4, instead of 4 into the total of 645, to make it easier, I want to know how many times 4 will go into 6. And then we'll individually move on to the 4 and the 5, and I'll show you guys how that works. So again, another place where it's going to be really helpful to know your multiples of numbers. I know it's been a long time since we've seen our multiples, so if you guys have any issues with that, it just takes some practice. It takes some practice utilizing your calculator along the way. After we get more in the swing of things, it becomes like riding a bike, and you can easily just get right back into it. But helpful at first. If you need to, feel free to use that calculator and help you. So we start with 4 into the 6. So what I mean is I want to know how many times will 4 go into 6 without going over. So 4 will only go into 6 one time. So I'm going to write that out. I'm going to put that answer right on top. That's where our answer is going to go in our problem here. So we said 1. because I know that 1 times 4 is 4, so I haven't gone over the 6. So what happens is we write that out. We take that and we multiply that 1 times 4, write that underneath here, so that when we subtract those two numbers, so I'm going to subtract those two, we get a remainder. So what happens here is if that 4 and the 5 weren't there, if it was just 6 divided by 4, that means every person, say if we only had 6 Skittles, so let me just write this off to the side. So if this was just 6 divided by 4, if we only had 6 Skittles and we were dividing those amongst one, against the 4 people, everybody would only get 1 Skittle and we'd have 2 left over. So that's what that looks like, is again, everybody's just getting the same amount, but since we can't divide 2 amongst 4 people, that's just what's left over. But since we don't have just that, we actually have more than just 6. We have 645. So what happens now is we keep going. Individually, what we're going to do is we're going to bring down each next value. So in this case, what I'm going to do, I'm going to bring down that 4 now. The 4 gets brought down and we put that right next to the 2, and we now have the number 24 down there. What we're going to do is the same thing we just did with the 4 into the 6. I want to now ask myself, how many times will 4 now go into 24? And we'll write our answer up at the top just like we did a second ago. So we'll just follow the same process. So again, ask yourself, how many times now will 4 go into 24? Again, without going over. And a way to think about that, the answer here is going to be 6. But I want to show you guys how you can kind of check yourselves along the way. If we didn't say 6, I'm going to write this in red to show that it's actually an incorrect answer. If I said 5, then 5 times 4 is 20. So when I write that underneath and get a remainder, my remainder is 4. If your remainder is ever the same as what we're dividing by, think about this. Again, if I have 4 Skittles left over, that means I could still give more to each person. So if it's either the same or larger than what you're dividing by, then we can go in another time. So we want to double check that, and I'm going to go ahead and erase that then. So it wasn't 4. Okay, well, let's say we went too big. Let's say, I don't know why that's not erasing. There it goes. Let's say we said 7. Okay, if we accidentally said 7, well, 7 times 4 is 28. Well, I can't subtract 28 from 24, so I've gotten too big here, so that's not going to work. So I'm going to erase that, and so that should be 6 in this case. 4 is going to go into 24 6 times. So I'm going to go ahead and write that answer in yellow just to match what we have up there. There's our correct answer. We say that because, just like we did before, I'm going to now take 6 times 4 and write that underneath as we did the first time. 6 times 4 is 24, so when I subtract, there's nothing left over. So if this was just, again, to show you guys what I mean by that, if that was just 64 divided by 4, if we had 64 Skittles, each person would get 16, and there would be nothing remaining, because that's what we have up there. There's no more Skittles left over. Everybody got an even amount. But again, we have more than that, so I'm going to go ahead and get that out of the way. And let's go ahead and follow the same step just like we did previously. I'm going to bring down that 5 now, and now ask myself, how many times will 4, just as we've been doing, how many times will 4 now go into 5? And 4 will go into 5 only one time, just as we saw at the beginning. 1 times 4, just like we did before, I'm going to multiply that and write my answer down here. 1 times 4 is 4, so when I subtract these two numbers, I have 1 left over. So that's what happens here. And that last one, we can just throw it out because nobody's going to get it. So to make sure everybody gets an even amount of Skittles, it looks like everybody's going to get 161. So if you were to double check this in your calculator, 645 divided by 4 is going to give you 161.25. Right now, we'll see those decimals when we get into our decimal chapter today. For right now, just go ahead and leave that as remainder. So you can just answer that as 161 remainder. So 161, and you can even just do this, remainder 1. In the next chapter, we'll see what to do and how we get to those decimals. So if we really were to go to, to make sure everybody gets the exact same amount, and we want to make sure that we divide that exact same amount of Skittles, we could actually take that one Skittle and divide it even further. But we're not going to do that because that's a little extreme. But this is just showing, you know, again, what's remaining. So we'll start there. So let me give you another example. Okay. And there's something else I want to show you guys in the next example. So this is an example that I've grabbed from the book. If I take 12,345, so 1, 2, 3, 4, 5, and I'm dividing it by 4 again. So let's say we have a whole lot more Skittles now, but the same 4 people want these Skittles, and we want an even amount. So what we're going to see here is if we have this amount, then we should be able to distribute these. So I'm going to follow the same process, maybe without drawing all those lines all over the place, but just kind of follow along here, and if you need me to, I can, you know, create another video to show all those lines, but I'm going to follow the same process. And I'll use my little pointer here to show you what I'm doing each time here. So just once again, I'm going to ask myself just one individual question one at a time. So 4 into 1. Well, you guys are thinking, wait, 4 can't go into 1. 4 is much bigger than 1. You're correct. That won't work. So what we have to do is move on to the next value. I'm now here at the 2. So since we haven't done anything to 1, we're going to look at this whole thing, this whole number, as 12. So instead, since we couldn't go into the first number, we're going to actually look at that second number and put those together. So now I'm going to ask myself, how many times will 4 go into 12? And we know that 4 goes into 12 3 times. And notice I put the 3 over top of the 2 that I had moved on to, because that's going to affect our answer later. We always want to move on and place the number over top of the number that we're working with. So we said 3 because, again, what we're going to do is multiply 3 times 4 and write that underneath here. So 3 times 4 is 12. So let me write that underneath, is 12. So I subtract, and that gives me a remainder of 0. So that means, again, if we had 12 Skittles and I was dividing that amongst 4 people, everybody would get 3 Skittles. But we still have more numbers to bring down, so just like we did before, one at a time, I'll bring each number down and write it next to my remainder, and now I ask myself the same question. Just like we did earlier with the 4 into the 12, now I want to know 4 into 3. Well, once again, just like we did with the 1, you guys are thinking, wait, 4 is bigger than 3, so how is this going to work? Well, here, once we've already started our answer up at the top, we have to have an answer written up there. So when we have a situation like this, where the number that we're dividing by, so again, the number of people that we have, if it won't go into this number that we're asking ourselves that question, once we've already started our answer, we have to have something up there. So in this case, we just say 0. 4 will go into 3 0 times, and that's a correct statement. It won't go in, so we just say 0. We didn't have to say that here at the beginning because a number is not going to start with the number 0, but there are zeros in the middle, and that's where that comes from. So 4 goes into 3 0 times. Some of you guys who were first taught division were taught to go ahead and bring that next value down, but I'm going to follow the same process we've been following. So I'm just going to say, okay, well, we said 0 because 0 times 4 is 0. So because of that, when I subtract, I get a remainder of 3. So I still want to show the remainder there. So now my next step is to bring down the next value, so to bring down my 4. So again, if you guys did that ahead of time and you all did that here at this spot, you still would have 34. Okay, so we're still asking ourselves the same question. So whether you did that here or you're doing it here, it doesn't matter. So now we're asking ourselves the same question, just like we did the 4 into the 12. We asked ourselves 4 goes into 3. Now I want to know how many times will 4 go into 34. Every time you bring a number down, you just ask that same question. Now how many times will 4 go into 34? 4 will go into 34 8 times, because 8 times 4 is 32. So when I subtract, that gives me a remainder of 2. Okay, so now same step. I still have that 5 to bring down, so I'm going to bring that down. Now I want to know how many times will 4 go into 25. And 4 will go into 25 6 times, because 6 times 4 is 24. Sorry, I'm running out of space down here, and I should have written that in red like I have been. And it is 24 because we get a not 0, sorry, we get a remainder of 1. So 25 minus 24 is 1, sorry about that. So that means that our answer is 3,086 with a remainder of 1. When you check in your calculator, once again, you're going to get 3,086.25. But again, decimals, I'll show you guys later how we can approach this from a decimal standpoint if we were to further divide that very last skittle. So here we'll just call it remainder. But that's where that comes in. I wanted to show you guys how we use those zeros as placeholders when that needs to happen. So we'll see some division in the next couple chapters, in the decimal chapter as well. But I wanted to show you that, and I hope that helps you to see that division there. So I know in both of those we just divided by a whole number. I'll show you guys in the next chapter what happens if we have to divide by something bigger. A few other things that the chapter 1 gets into with our whole numbers that we take a look at. We do more than just the addition, subtraction, multiplication, and division. We're also going to take a look at then finding what's called the mean, median, mode, and range. So taking a look at that, so that's the next step. So just writing these different things out, we see the mean, the median, this is horrible handwriting, sorry, mode, and range. So in your book, it's titled The Basics of Statistical Analysis, which sounds like a crazy, awesome tongue twister that when I can do this, that must mean I'm super smart, and it does, but also can sound kind of intimidating. But what it means when we're dealing with any type of statistics, it just means that we're dealing with a group of numbers. So whether it's everyone's ages, I took a poll of everyone in the class and, found out what everybody's ages are, and that's, statistics. It's the age statistics of my class. Or perhaps on the nursing home unit that I work on, I went around and collected blood pressures of all of my patients, and so collecting all of those blood pressures, I'm now dealing with my blood pressure statistics. So that's all statistics are, it's just a group of numbers. When we analyze those statistics, so that's what this means, statistical analysis, when we analyze those, we can do a couple things with those. And that's what we're looking at here. These 4 things, we're looking at the mean, the median, the mode, and the range. We can take that group of numbers and study it a little bit further. So what I mean by that is, by the mean, for instance. The mean is something that's commonly done with statistics. It's another word for mean is the average. And a lot of you guys may have heard of the word average. What we do when we have a group of numbers, by averaging those numbers, I can see kind of what, the average score tells me what, how, like in our grade book. When we look at our quizzes throughout the quarter, let's say, I just want to use this as an example as I explain this. If I got an 87, a 93, a 100, these are all my quiz scores for the quarter. And, I'm looking at these, in a statistical, way here. Let's see, then I got, let's say, an 89. And then how about another 100? So looking pretty good. So here I'm looking at all my quiz scores so far for the quarter. I've taken 6 quizzes. The mean or the average tells me what my kind of collective score is. Even though my lowest score here is an 87 and my highest score is a 100, so it takes the average of those, and in the grade book, it tells me kind of collectively how I'm doing on my quizzes, in an average. And so that's a very common thing that we do with statistics, with these groups. So we're going to go ahead and do that here. And so how we find the average, we take this group of numbers. What we're going to do is we're going to add all of them together. So we're going to add together 87 plus 93, and I'm going to do that as we're going through this example here. 87 plus 93 plus 100 plus 95 plus 89 plus 100. So I take those 6 scores, I get a total of 564. So I'm going to write that down up here. So I get a total of 564. Now that's not my average yet. Obviously that's not, again, like I said, we find the average to see collectively how I'm doing on tests, and it's not 564. What we do is we take the sum of those numbers and we divide by how many tests we have, or how many numbers we have in that group. In this example, we're using tests. So since I have 6 scores, I'm going to take that and I'm going to divide by 6. If I had 5 test scores, I would take it and divide by 5. If there were 10 tests up here, I would add them all together and divide by 10. So that's the idea, is to just divide by how many numbers we have in that set. So when I divide that by 6, I get an average of 94. So that tells me I'm looking at an A so far this quarter, because I have more A scores than I do B scores there. So my average is a 94. So that's the mean. So again, we find the mean by taking all those numbers, adding them all together, and then dividing by how many numbers we have in that set. Another thing that we can do with large groups of numbers, so with our statistics, we can find what's called the median. Now the median is the, whenever I think of the word median, and I just erased that mean there, I'll go ahead and put that back up there, 94. The median, whenever I think of median, I think of, there's medians in the middle of the road, in the middle of the highway. There's a median going down the middle. I always just associate that with the word middle. And that's exactly what this term means. Median just means number in the middle. So in order to find the number in the middle, we have to first put them in numerical order. I can't just randomly grab the number in the middle of the scores that I see here. It has to be in some type of numerical order. So I'm going to put it in order from smallest to largest. So my lowest score is is an 87. Then I got a 90. Oh, messed that up there already. It's an 89, then a 93, a 95, and then I had 2 100s. So sorry, that's kind of sloppy there. Now, let's say if this last 100 wasn't here, if that last 100 wasn't on the screen there, so I'm just going to go ahead and erase it. If you're looking at our scores right here, you would see we have an 87, 89, 93, 95, 100. Therefore, the one in the middle, my median would be 93. There it is, smack dab in the middle of all these numbers. But what happens when I have, again, when I took that last score there and I got that 100, when I have my 6 numbers up here, what it does is it's going to put 2 numbers in the middle. When that happens, when you have an even set of numbers and you have 2 numbers in the middle, it's not those 2. What we actually want to find is what is in the middle of those 2. Now, between 93 and 95, obviously we know that that's 94. That's really easy. But it's not always going to be that easy. So whenever there's 2 numbers in the middle, what you can do is just find the average of just those 2. The same way we found the average a second ago when we were finding the average for all of these numbers. The average was adding them all together and then dividing by 6, because we were looking at the average for all 6 of these numbers. But if I'm trying to find the median and I just want to find the average of these 2, it's simply just taking 93 plus 95 and then dividing that by 2. When that happens, 93 plus 95 gives me 188. Dividing that by 2 is 94. So it just happens to be kind of coincidental here that my mean and my median happen to be the same number. That won't always be the case. And again, it won't always be as easy as just halfway between 2 numbers that we know the number in the middle off the top of our head. So an easy way to do that is to find the average of just those 2. So again, just a refresher on the median. The median is the middle number, but if there are 2 numbers in the middle, then we just take the average of those 2, and that will help us to find what's exactly in the middle of those 2. Now the mode I always associate with the word most. I always think mode means most. And that's exactly what it is. Our mode is our most repeated number. So the number that's used the most, or the most popular value, however you want to think about that definition. So it's just easy to spot a lot of times because it's just the number that's been used more than any of the others. And in this case, we did have 2 100s out of the whole quarter here. All of our scores, nothing repeats itself except for that 100, and so therefore, since that was used more than the others, that's our mode. Sometimes there will not be a mode. Maybe if on that last exam, maybe I got a 99 instead of a 100, then therefore there would be no numbers that have repeated themselves. And in that case, the answer would just be no mode. In all of the tests or assignments that I give to you, though, anytime I ask you for a mode, there will be a mode. So it'll be something really easy to spot. It's just the number that's used the most often. So remember that mode means most. And then lastly there, the range. The range is simply, when I think of a range, I always think of, the range of whatever it might be. I'm thinking from here to here. And that's kind of the same idea, but in this case what we're going to do is we're going to take our largest test score, which again was 100, here it is down here at the end, and I'm going to subtract the lowest test score. By taking my highest test score and subtracting the lowest test score, it tells me the range of points that I have between my lowest and my highest test score. So my range here is 13. And that's how we find that. We simply just take the highest number and we subtract the smallest number. And that's how we find the mean, the median, the mode, and the range. And so that's exactly how that will be given to you on your quizzes. On the homework, I believe there's a different question, and same thing within the ebook there. There's a different question for each category, that it gives you a group of numbers, and then it asks you to find the mean for those numbers. Then there's a separate question. It gives you a different set of numbers, and it says, okay, find the median for this group of numbers. But on the quiz, you'll see something like this, where I will give you just a random group of numbers, whether it's test scores or just anything else. It could be something completely different. If that's the case, then I'll just give you this group and then want you to find the mean, median, mode, and range for that group. So that's how we do that. So again, as a refresher, mean is the average. So we add all those numbers and divide by however many numbers we have in that set. Our median is the middle number. Our mode is the most repeated number. And our range is the largest minus the smallest. So it's the difference between those two numbers. So you'll get some practice with those using the homework on the My Math Lab homework. You guys will see that. And then the last thing that is covered in this chapter, you may notice, I believe your book does mention Roman numerals. I don't necessarily test you guys on Roman numerals just because it's not something that's used very often anymore. It's kind of outdated. Roman numerals are actually really, really simple once you get to know them. It's simply just addition and subtraction. It's just a matter of getting to know what the letters represent. So like V means 5 and I means 1. So it's just adding those two together. If the smallest number is behind the highest number or the large number, then it's addition. Since this means 5 and this means 1, since the bigger number is the one first, and then the smaller number is the one second, then it's addition. So that would just be the Roman numeral for 6. Whereas if the 1 was in front of the 5, then because of that, it's a subtraction. It shouldn't be like that. It's 5 minus 1. Obviously not 1 minus 5. It wouldn't be a negative. But then in that case, it's just subtraction. So you just subtract the two numbers, and this is the Roman numeral for 4. So just kind of a quick here's what Roman numerals are, but again, you're not going to be tested on those. You're not going to see those really anywhere in the healthcare field, but maybe rarely. So it would be something that you could quickly just look up and see. The only time I think you guys will ever see Roman numerals is probably on Super Bowl Sunday, and at that point, you'll know what that is. But that's pretty much it. The last thing, though, I do want to cover is military time. Military time is very important in this chapter and in the healthcare industry, as one of the biggest issues that sometimes happens. If I were to maybe administer medication to a patient, and I wrote in their chart that I administered that medication at 9:30, and then I put the chart down, walked off, and then got off my shift and went home. Now what happens is the next person who comes in to administer medication to this patient, they see this. And they don't see whether or not that patient's medication was given this morning or tonight. So, things like that it just happens to be an issue with the fact that there are, two AMs and PM. I'm sorry, there's two 9:30s in this case. There's an AM and there's a PM. And that's what happens on our 12-hour clock. So military clock is just slightly different. Instead, it's just a 24-hour clock that only goes around one time in a day. We're used to a 12-hour clock that goes around twice. That's why there's two 1 o'clocks. There's two 2 o'clocks. There's an AM versus a PM. So let me walk you guys through this and kind of introduce and show you exactly what I mean by that. Today started on our clock at 12 a.m. The day begins at midnight. That's just the start of the new day. On a military clock, this looks like this: 100 hours, 0000. What happens in military time? The first two digits represent the hour. So the 12 o'clock is represented by 00. Because it is the beginning of the day, we haven't gotten into the first hour. So because of that, the time is just 00. We haven't even started our first minute, and our minutes will always be the same on a military clock. So because the clock just struck 0, we haven't gotten into an hour or a minute yet, so it's all zeros. I know for some of you guys, if some of you guys were taught 2400, that is correct for midnight, but I tend to avoid that because of this. That 1201, 1201, silly, is on a 12:01 a.m. on the military clock is 00 because it's still that 12 o'clock hour, so we're not into a full hour yet, and your minutes just stay the same. So it's just 01. This is the only time to represent 12:01 a.m. Sometimes when people use 2400 for midnight, their temptation is to want to put 2401 as 12:01 a.m., and that is definitely an incorrect answer. You'll never go over 24 because there's not more than 24 hours in a day. So that is a time that does not exist. So again, I tend to kind of stay away, and I recommend that for you guys. Stay away from that 2400 for midnight, because I don't want you to start any of the other 12 a.m. times with 24. But that's how that works. Military time is always 4 digits. The first two digits represent the hour, the second two represent the minute, and the minutes will always be the same on both sides. But what happens is then when we get to 1 a.m., as I mentioned, before 12, we weren't even into a full hour yet. Here we have gotten into our first full hour. So we write that as 01 as the hour, and then our minutes stay the same. So 1 o'clock a.m. is just 0100, whereas it would just continue to follow that trend. 2 o'clock a.m. would be 0200, and so on and so forth. And like I said, the minutes just stay the same. So 3:30 a.m. would simply be 03 for the hour, and then 30 for the minutes. So really, for the most part, all of your AM times pretty much stand as is. They're pretty much the same. That, again, they're all going to look very, very similar. 8:15 a.m. is just 08:15. 9:45 a.m. is going to be 09:45. Even when we get into our first double-digit hour, here's where we have 10 o'clock, 10 a.m., well, we've just gone from 09. The difference is we just don't have to put a 0 in front of it. 10 a.m. is just going to be 1000. The first two digits are represented by the hour there, so 10, and then 00 just matches. 10:15 a.m. would just be 10:15. 11:27 a.m. would just be 11. Oops, lose my marker here. 11 for the hour, and then 27 for the minutes. So again, all of your AM times look very, very similar to what they look like on the standard side. So what our traditional clock looks like, our traditional time. The only exception is really that midnight. That midnight, obviously, we don't normally see that as 00. It's just when we then start going over, then our traditional clock counts over and starts at 12 again. But we've now entered into 12 p.m. What the military clock does is it simply just continues to count forward. This would just be now 1200. So you can see the very distinct difference between 12 a.m. and then here's 12 p.m. That at 12 a.m. the day has just begun, so we see zeros there. And then at 12 p.m. we're halfway through that 24-hour day, so we're going to start our time with 12. So 12:30 p.m. would just be 12:30. And then we get into our, continuing forward, our 1 p.m. like I said, the military clock just continues to count forward. So there's 1300. 2 p.m. would be 1400. 3 p.m. would be 1500, and so on and so forth. So here is where we're seeing some slightly different times, where we're starting to see things that we're not quite used to. Again, some of those morning times, that was kind of easy to remember that 8:30 a.m. is 0830, that it looks very similar. That 9:47 p.m. is, 9:47 a.m. is 0947. It looks very, very similar. It's these afternoon times that are different. For those of us that aren't really quite used to military time, these are the ones that are different for us. So when I have a time in the afternoon or after 1 p.m., there are a couple steps that we can use, a couple tricks that might help us. There's what I call the plus 12 method. This is for any time that is after, and this only works after 1 p.m. If you have a traditional time that's after 1 p.m., then what you can do is you can take that time, so let's say it's 3:45 p.m. It's after 1 o'clock p.m. What I can do with the plus 12 method says that I can just add 12 to the hour, and again, just keep the minutes the same. So the hour just becomes 12 plus 3, which is 15, and then your minutes just stay the same. So we get 15:45. And that's our time in military time on that 3:45 p.m. Whereas then if I had, let's say, 8:17 p.m., still a time that's after 1 p.m., so I can use the plus 12 method. So 12 plus 8 gives me 20, and then the minutes just stay the same. So I get 20:17 there. So that's a way that we can remember those times that are after 1 p.m. And again, it can't just be any p.m. time. As 12:30 p.m., this would not work. This is a time that's just before 1 p.m. If I did add that 12 to it, then now we're getting 24:30. And again, that time does not exist. So that does not work for those 12 o'clock p.m. time. So that plus 12 method does not work for any p.m. time. It only works for any time that's after 1 p.m. Now, the other method that you could use is the clock method. The clock method says that we can just take our standard clock, what we're used to seeing. We draw 1, 2, 3, 4, 5, 6. We're used to seeing, what our typical clock looks like. Here's 10, 11, and then 12. What happens as I draw 1 through 12, now I can just keep going on the outside. Out here at the 1, start at 13, 14, 15, and I'm just going to draw all the way through 23 here on the outside. There's 20, 21, 22, and 23. What this clock method then shows us, we can show the inside times, our AM times, our outside times, or the PM times, with the exception of our 12s. Our 12 midnight starts 00, and then 12 p.m. is 1200. So that's kind of our exception if we use the clock method. But what's great about the clock method is anytime you get that you're not so sure about, if say, again, if it's an AM time, 2:25 a.m., well, sorry, that ran out of room there, then that's inside of our clock, so that just reminds us that it stays the same, so that's going to be 02:25. Whereas if it was opposite that, let me get this out of the way here. If it was 2, and let me write this down over here, if it would let me get to my marker, there it goes. If it was, say, 2:25 p.m., what am I writing today? I'm sorry, guys. 2:25 p.m., well, I can see that, here's my 2. Outside the clock is 14, so because the PM times are outside the clock, that means this is 14:25. So that's just a way to see, those PM times, they match up with that, and it helps with those. If we tell ourselves that the morning times pretty much stand as is, and then the afternoon times, we see those on the outside of the clock, and that helps us with those. After some time and after some practice with these, the more you see them, the more you'll be able to just spit them off and not have to use the plus 12 method or even the clock method. But this just makes it easier just here at the beginning as you're learning these different methods. So that can be pretty helpful. Using either method, whichever method you're more comfortable with, you'll want to be prepared to see both sides. What I'll do on a test, or what I'll do on even on your homework, I may give you a time in military time as well. And vice versa. I may say, okay, well, what is 5:45 p.m.? So you can either, again, it's after 1 p.m., so you could use the plus 12 method, or you can have your clock drawn somewhere on the side and see that, okay, well, it's a p.m. time, so I go outside of the 5, and you would see that outside of the 5, you would see 17. So writing this answer would be 17:45. Again, no need to write any colon between our hours and minutes to write that on military time, and there's no need for AM and PM because they're at 17:45. There's only one 17:45. That's all you're going to use there. But also, like I said, be prepared to see that the other way. I may on a test question say, okay, well, what is 23:14? This is the military time that I'm giving you. If I said, taking the time here in military time, what is this time in traditional time? So now we've got to go back the other way. So I know that this is past, again, remember 1 p.m. is 1300. So, and this is a much bigger number. So I know for sure this is a p.m. time. If we're using that clock method, we would see that the 23 is right across from the 11. So that 23 there is the same thing as 11. Or if you're using the the plus 12 method, when you're going the opposite way from military time to traditional time, then all you have to do is subtract 12. So you could do that as well, and 23 minus 12 would give us 11. So either way, this would be represented as 11:14, but then again, because we're going back to traditional time, I need to see that that means 11:14 p.m. Remember, there's two 11:14s in that traditional time, so I need to know which one it is. So we make sure that we answer that way. So you see them both ways. There's some practice. You guys will see those military questions. And if it helps, like I said, on a piece of scrap paper, maybe draw off to the side that clock, if that's the method you want to use, or have, the ability to write plus 12 or minus 12 if you're using that method off to the side. So that's everything from Chapter 1. You guys will see today we're also going to take a look at Chapter 3, and I'll have that lecture posted for you as well. So please remember to let me know if you guys have any questions at all. Thank you.